Hello and welcome back to Math 055. This is a video over section 7.2, which is about rational numbers as exponents. Okay, so what we're going to do, we talked about exponents in the last section, but we want to talk about rational numbers. And rational numbers, just to clarify, these are what we're going to call fractional exponents. Okay, so fractions as exponents. Okay, the first thing I want to do is to go over the laws of exponents. I don't want to go over in detail how we get these, but the laws of exponents are as follows. If I have a to the first power, anything raised to the first power is just going to be the base, so that's just going to be a. Okay, an example of that would be like 2 to the first power would be 2, okay? The second one where it says a to the 0 power, that would be 1, okay? And anything raised to the 0 power, even 0 raised to the 0 power, is just going to give me 1, okay? If we multiply the numbers with the same base, then we add our exponents. So if I wanted to do this one, I would say that this is a to the m plus n power. Okay, if we are dividing numbers with common bases, okay, then we would subtract our exponents. So this would be a to the m minus n power. All right, on part 6, a to the m all raised to the n, if we have an exponent raised to an exponent here, then we multiply our exponents, and this is going to give me a to the m times n power. This should look more like a subtraction symbol, okay. Sorry, that looks kind of weird. On number 7, if I have the product of two numbers all raised to the n power, then I would raise each of those, a to the n times b to the n. Okay. In part 8, if I'm dividing two numbers and I'm raising all of that, then I raise each of those to the nth power. Okay. So if you have more questions on these, on how I get these and how I know them, we can go over that, but I just want to make sure you guys have those the way you do, okay, just because this is kind of a review. Okay, so then we also have this where we have laws of negative exponents, okay, and this would be where I'd have a to the negative n. If I have an a to the negative n, then I'm really just writing this as 1 over a to the n to make it positive, okay. If I have 1 over a to the negative n, then what I want to do is I want to bring that up top, and I would just write that as a to the n, okay? In part 3, it says a over b all raised to the negative n power. Then really what I need to do is, well, you do look at this a number of ways. I'll do this kind of the long way. I'll raise each of these to the negative n power. Okay, so b to the negative n, a over a to the negative n over b to the negative n. And then what I want to do is I want to switch them, okay? And that's kind of the idea here, is that, I put this over 1 and I bring this down below. When you have negative exponents, you really just move them from the numerator and denominator to make them positive. So this would really be b to the n over a to the n. Okay, and so those are our laws of exponents, okay, in a very brief explanation. I could make a whole video an hour long about how we get those, but those are, our properties, okay, and we need to know those. So what I want to talk about is this. Rational numbers as exponents. Let's think of something here. Let's just think of, what happens when I take, like, say, 2 and I square it. And so when I do this, what I'm doing is I'm really doing 2 times 2, okay, multiplying 2 by itself twice, which is going to end up giving me 4, okay. Let's think of something like this, where I have 3 squared is equal to 3 times 3, all right, and that's going to give me 9. Okay, so this is using exponents, okay, I'm going to write that up here, using exponents. Okay, now what we have is now I want to go the opposite direction. Okay, what's the opposite? Like, what do I have to do to 4 to bring this back and give me 2? Okay, so the opposite operation would be this. It would be to take the square root of 4 would bring me back to 2. Okay, if I take the square root of 9, it brings me back to 3. Okay, so this concept of a square root is something that's a little bit interesting, okay? So what I want to talk to you guys about is this concept of rational expressions or rational exponents, okay? And let's think of the example of 3 squared, okay? If I were to take 3 squared, I know that's going to give me 9, okay, right? And I know that the square root of 9 is going to give me 3. My question is, why does this work? Okay, and here's why. Okay, let's think of this. Let's think of 3 squared. Okay, and if I take the square root of that, we know that 3 squared is 9. Okay, and if I take the square root of that, it's just going to bring me back to 3. Question again is, why does that work? Okay, so let's think about this. All right, let's think of, what if I were to raise this to a rational exponent? Okay, what if I did 3 squared and raise that to the 1/2 power? Then we have to think about our rules of exponents. If I take an exponent, raise it to another exponent, that means I multiply my exponents. So what I end up getting here is I get 3 to the 2/1 power times 1/2. And if I take 2 times 1/2, 2 times 1 is going to give me, it's going to give me 3 to the 2/2 power, which gives me 3 to the 1st power, which is just going to give me 3. This is why that works. Okay, so now let's think of something else. All right, let's think of, say, 3 cubed. All right, 3 cubed, we know that to be 3 times 3 times 3, which is going to give me 27. All right, and what I know is to go backwards. If I wanted to take, say, the cube root of 27, which we've talked about, that's going to end up giving me 3. Why does that work? Okay, so the cube root of 27 is really just taking 27 and raising that to the 1/3 power. And that's how I get that. All right, and so, the way I think about it is, instead of doing 27 to the 1/3, I rewrite that as 3 cubed. So this is really just 3 cubed to the 1/3 power. 3 times 1/3 is going to give me 3 to the 3/3 power, which is 3 to the 1st, which gives me 3. Okay, so all I'm doing, guys, is I'm kind of just going in a circle, and I'm kind of just doing, I'm starting somewhere, I'm raising something to an exponent, and then I'm bringing it back, okay? Remember when we have opposite operations, and we call these inverse operations, okay? So inverse operations, all right? And when I do that, what I want to think about is this. What's the opposite of addition? And that's subtraction. What's the opposite of multiplication? And that's going to be division. Okay, well, what is the opposite of squaring something? Okay, and that would be taking the square root of that number. Okay, brings me back to what I need. All right. And so what I wanted to think about is, what if we do this to any exponent, x to the n? Well, then what we're doing is we're taking the nth root of that number. Okay, and what I want you to think about is really that this is just x squared. Instead of, always doing square roots, I can think of this as rational exponents. Okay, and whatever root I'm using here, that would be the denominator when I do that. So x raised to the 1/n power is the same thing. These two things mean the same thing. Okay, so let's talk about this a little bit more in detail. All right, and so we have this concept of converting a rational exponent to a radical and vice versa. Okay, and so we've already kind of talked about this. Okay, so if a is a real number, n is a positive integer greater than 1, and the nth root of a exists, then I can rewrite the nth root of a as a fractional exponent. Okay, and same thing, if m over n is a rational number, then n is a positive integer greater than 1, and a is a real number such that the nth root of a exists. Then if I were to take a to the m over n power, that would be equal to the nth root of a to the m. which is equal to the nth root of a to the, or the nth root of a all raised to the nth power. All right, so let's kind of talk about this. Let me give you guys an example that's pretty useful here. One of my favorite problems to do is 8 to the 2/3 power, okay? And this is a hard question. A lot of people get screwed up with this, and there's a couple different ways to think about this. So here's one way to do this problem, and let me do the second way. All right. And so one way to do this is I'm going to rewrite it, a to the 2/3 power. And what I have is I'm going to rewrite this like this. I'm going to write it as the product of two exponents. I'm going to say 8 to the 2/1 times 1/3 power, okay? And all I'm doing is rewriting this as the product of two fractions, okay? And I'm taking my numerator here, moving it out, putting it over 1, and then replacing that with 1, okay? And when I multiply my exponents, remember that what I have is I have 8 squared raised to the 1/3 power, okay? And so what that ends up giving me is this 8 squared is going to give me 64, and that's going to be raised to the 1/3 power. Now this is something that you can actually put in your calculator and evaluate, and that's how I learned this, because I would always be like, well, wait a minute, this is really just the cube root of 64. Well, how do I do that? And my teacher was just like, raise it to the 1/3 power. And that's how I learned these. And so it was more just kind of like I kind of stumbled upon it as opposed to, learning it this way. But, when I do that, I think of, okay, what three numbers multiplied together give me 64 would end up giving me 4. Okay, and here's how I check that. I'm like, okay, if I'm trying to do this problem, all right, and evaluate the cube root of 64, or 64 to the 1/3 power, what I want to think about, all right, well, what's 4 cubed? That should give me 64. What's 4 times 4 times 4? Well, 4 times 4 is 16. Multiply that by 4 again, and yes, that's going to give you 64, okay? Now, the other way to do this is kind of a trickier way, okay? I struggle with this one. Okay, the second way of doing this is to do 8 to the 2/3. Okay, let's split that up. And instead of doing 2/1 times 1/3, let's do 1/3 times 2/1. Okay, and so if I do this, then what I'm really doing is I'm doing 8 to the 1/3 power all squared. All right, and if I do 8 to the 1/3, this problem to me is a little bit easier. Okay, I'm really just taking the cube root of 8 and then squaring it. Well, the cube root of 8 is 2. And if I square 2, it's going to give me 4. Okay, and so to evaluate, the cube root of 8, that might be a little tricky for you. All right, the cube root of 8, what three numbers multiplied by themselves give you 8? Okay, and that's going to give you 2. And if you can check that by doing 2 cubed, that's going to be 2 times 2 times 2. 2 times 2 is 2 times 2 again gives you, 2 times 2 is 4 times 2 again is going to give you 8, so that works out. Either way, in the end, you get an answer of 4, okay? And that's the idea. All right, so we can do this a couple different ways. And that's basically what all of this explanation is, okay, is rewriting that. So it kind of just depends on how you want to do that. All right, so now what I want to do is kind of fill out this table here to talk to you guys. And we have exponential form, or rational exponent form, and then we have radical form. For rational exponent form, I have 7 to the 1/5. That's the same thing as doing the 5th root of 7, okay? So being able to just go from here to here is important, all right? The radical form here, now you have a radical form. 4 is what we call your index, and 3 is your exponent. So what I always do is I do this. This number here is your denominator, okay? And so I'm going to take 5/3, or 5 to the 3rd power, and then raise that to the 1/4 power, okay? And that's really just going to give me 5 to the 3/4 power, okay? Taking this whole thing and turning this into, you have this rational exponent of 2/3. What I'm going to do here is I'm just going to rewrite this as the cube root. Okay, that's my denominator. 3 is my denominator here. So that number goes out here. And then I'm just going to leave what's inside, which is x to the 5th, y squared, z cubed, and then I'm going to square that. Okay. Now these two last problems down here are kind of tricky. I had to kind of look at them because I'm like, wait a minute, what are these going to be? This one, so let's do this. Let's do the nth root of a to the negative 1 power. Okay, and if I have a to the negative 1, really I'm just going to write that as the nth root of 1 over a. Okay? A to the m over negative n power, I can rewrite this. I don't necessarily have to keep, when I think of m over negative n, I could really rewrite this as a to the negative m over n. These are equivalent statements, okay? And what I want to do is then simplify this and say the nth root of a to the negative m power, which would be the nth root of 1 over a to the m. Okay, so these last two are pretty tricky, and a lot of these questions can be a little tricky, but we just need to make our way through them. So I know this is kind of a weird thing where I'm just you may feel like I'm just like rewriting stuff, but that's kind of what the idea is your ability to look at something as a rational exponent and rewrite it in radical form and vice versa. Okay, so let's take a look at the next page and do some practice problems. All right, so on this first set of examples, what I want to do is write equivalent expressions using radical notation and, if possible, simplify. Okay, so what I want to do is this. So I'm going to take a to the negative 1/2 power, and I'm going to rewrite this as 100, the square root of 100 to the negative 1 power. Okay? And what that's going to give me is it's going to give me the square root of 1 over 100. Okay? And what I can do from that is I can take the square root of 1 over the square root of 100. Now, the square root of 1 is just 1. The square root of 100 is 10. So the answer here is 1/10. Okay? All right, let's take a look at part B. And so if I have the quantity negative 4 over 25 raised to the 1/2 power, really what I'm doing here is I'm taking this entire thing and I'm taking the square root of this fraction, which is negative 4 over 25. Okay, and what we could do is we could take the square root of negative 4 over the square root of 25. Now, what I can't do is I can't take the square root of a negative number. Okay, so I can't do that. Can't do this. Okay. However, I can take the square root of my denominator, which ends up giving me, so that would be the square root of negative 4 over square root of 25, which is just 5, and we could leave it like that. Okay, leaving it like this would also be appropriate, just kind of depends. Okay, when you throw those negatives under the square roots, kind of screws things up a little bit. All right, let's do this one. I like this one. Let's rewrite this one as, and we can do this a couple different ways, but let's do this one as the cube root of 27 over 63, and then let's square it, okay? Now, what I could do is I could square 27 and then take the cube root of it, or I could square 64, not 63. And then I could square that and then take the cube root of it. That, without a calculator, that's kind of hard to do. You could definitely do that on the calculator, but to simplify this algebraically and to be able to do it on paper, which is important to do, let's do it that way instead. So let me separate this out and do the cube root of 27 divided by the cube root of 64, and then I'm going to square this whole thing. Okay, now the cube root of 27 is really just going to be 3. Okay, 3 times 3 times 3 gives me 27. Cube root of 64 is going to end up giving me 4. So I have 3/4 raised to the second power. Okay, so now what I want to do is I would take 3 and I would square it, and I would take 4 and I would square it. So 3 squared is going to give me 9, 4 squared is going to give me 16, and that's my answer. Okay, all right, on this last one, or we got a couple more, On part D, I've got negative 9 raised to the negative 5 halves power. Now for this one, what I want you to notice here is that the negative symbol here is out front, okay? Which means this is the same thing as doing negative 1 times 9 raised to the negative 5 halves power, okay? So that's kind of nice. If we had, parentheses around the negative 9, then we would include that negative. But when we don't have parentheses around that, we don't include that. All right, so that's kind of a little nuance with this. So let's write this now as negative 1 times the square root of 9 to the negative 5th power. All right, then this is going to give me negative 1 times the square root of 1 over 9 to the 5th power. Okay, and 9 to the 5th power is a pretty large number, and that's going to give me negative 1 times the square root of 1 over 59049. Okay. And I would just leave it like that, because we can't take the square root of 59049. Well, and actually we can. I just double checked on the calculator. So, all right, check this out. So here's what we get. All right, what I can do is I get negative 1 times the square root of 1 divided by the square root of 59049. And so the square root of 1, let me rewrite this. Here's what we're going to get. Okay, so we've got negative 1 times 1 over 243. Okay, we can take the square root of that. So we do end up getting negative 1 over 243, okay? And that's how we do those, okay? So not too terrible. All right, let's take a look at this one and all the other ones we were doing with numbers. So let's do this with some variables here. And so on this one, I want to rewrite this as the square root of 9y to the 6th, and then we're going to cube that. All right, if I take the square root of y to the 6th, then really what I want to do is I want to take half of 6. So we're going to get the square root of, well, let's do this. The square root of 9 times the square root of y to the 6th, okay, all cubed. The square root of 9 is going to give me 3. Times the square root of y to the 6th is just going to give me y cubed. Okay, and then we're going to cube that. And so then we're going to get 3 cubed times y cubed cubed. A lot of 3's going on here. All right, so now we've got 3 cubed, which is going to give me 9, and then times y to the 9th power. All right, or what? Not 9. Should give me 27 times y to the 9th power. Okay, now what I want to do is talk about this, the concept of taking the square root of y to the 6th. Okay, when I'm taking the square root, really what I'm doing here is I'm doing y to the 6th, raising that to the 1/2 power. Okay, and then when I do y to the 6th times 1/2, it's really y to the 6th over 2, which is going to give me y cubed. And that's why the step going from here to here goes from the square root of y to the 6th to the y cubed. Okay, all right. So that's that. All right, so a lot of stuff going on there. Okay, let's take a look at these guys. All right, and it says simplify, leave your answer using positive exponents. So what I have here is I've got 5 times a squared times a to the negative 1/3 times a to the 1/2. So really what I want to do here is just operate with these fractions, okay? Because I can't turn these into radicals and then operate with them. I can operate with rational exponents, but I can't do those with radicals. So what I want to do is I'm going to rewrite this as 5 times a, and because I have the same base and I'm multiplying all of these, I'm going to add my exponents. I'm going to do 2 plus negative 1/3, okay, and then plus 1/2. All right, so if I were to do that, let me do this and get a common denominator. let me do 2 over 1 plus negative 1 over 3 times, or I'm sorry, plus 1/2. My common denominator would be 6. So I'm going to multiply this by 6 over 6. I'm going to multiply this by 2 over 2, and this one by 3 over 3, okay, to get a common denominator. So what I want to do here is I'm going to get 5 times a to the 12 over 6 power plus negative 2 6, okay, and then plus 3 6. All right. So as a result, what I'm going to get is I'm going to get 5a. 12 minus 2 is 10, plus 3 gives me 13, so this is 13 sixths, and that's my answer. Okay, now I could also write this as 5 times the 6th root of a to the 13th. Okay, either way. On this, it just wanted me to write it using positive exponents with that one. Okay, now with this one, all right, part B, what I want to do is I'd want to subtract my exponents. So I got to combine my a's and then my b's. So my first step would be this. For a, I'm going to do a to the 3/4 minus 3/2 power times b to the negative 1/3 minus 1/6 power. Okay, so let's get a common denominator for this one for the a's. Let's get a common denominator of 4. So I'm going to multiply this by 2 over 2. On this one over here, I'm going to multiply this by 2 over 2 to get common denominator 6. Okay, so let's rewrite this now. I've got a to the 3/4 minus 6/4 times b to the negative 2/6 power minus 1/6. Okay, and so now here's what I've got. I've got a, 3 minus 6 is going to give me negative 2 over 4. Okay, and then times b to the negative 3 over 6. Now each of these can be simplified, and I'm going to get a to the negative 1/2 times b to the negative 1/2. Okay, and so we're raising these to the same power, and so what I want to do is take, I can rewrite this now as 1 over a to the positive 1/2 times b to the positive 1/2. Okay, and then, really what I'm doing here is I'm doing 1 over a times b raised to the 1/2 power, which is really just going to be 1 over the square root of ab. Okay, this is kind of the preferred one. Either one of these would be okay. They all mean the same thing, but just kind of depends on what how you want to write it. All right, let's take a look over here on this one. And writing this, so let's do this. Let's take, we want to write this with positive exponents. So let's just take all of these, each of these, and raise them to the 2/3 power. So I'm going to do negative x cubed, okay, raise that to the 2/3 power, times y to the 6th, raise that to the 2/3 power, times z to the negative 6th power and raise that to the 2/3 power. So what I want to do is multiply these now. All right, so this is going to give me negative x to the, and let's do to the 6/3 power. Okay, so 3 times 2/3 gives me 6/3 times y to the, let's do 12/3 power. So 6 times 2 is 12. Sorry, I was thinking about something. And then times z to the negative 12/3 power. Okay, let me put this in parentheses here. We need to include that negative because that negative is inside of this. Yeah, this one, that's what I was looking at, is this negative out here. This negative, because we are squaring it, we do want to keep it inside of the parentheses. We don't want to keep it on the outside. So that is okay. If we have parentheses around that and we have a negative on the inside, because of this 2 here, we'll be okay. All right, so now let's simplify these fractions. And so this is just going to give us negative x, 6 over 3 is to the 2nd power, times y to the 12 over 3 power, which is 4. and then times z to the negative fourth power. Okay, if I take negative x and square it, it's really just going to give me positive x squared times y to the fourth, and then z to the negative 4, I would put that down in my denominator and make that as a positive exponent. All right, so I could do it that way. All right, there's a couple other ways of doing that problem, but I think that way is probably the easiest. And that's something that you guys will find out with these, is that there's a number of ways of doing them, just depending on what you've got. Okay, so on this, it says use rational exponents to simplify. Do not use fraction exponents in the final answer. Write your answers using radical notation. All right, so if we can simplify these, let's just go ahead and simplify. And what I want to do is rewrite this. You know, when I have y to the 15th, if I'm taking that to the cube root, I'm really raising this to the 1/3 power. Okay, and if I multiply my exponents, 15 over 1 times 1 over 3, y to the 15/3 power, which gives me y to the 5th. And that's it. That's my answer. Okay, so that one works out pretty well. Let's take a look over here on this one. This is going to be x to the 4th, and I'm going to raise that to the 1/12 power. Okay, so from here what I want to do is I want to do x to the 4 over 12 power, okay, when I multiply those together. And each of these are divisible by 4, so I can simplify this. And I can really write this as x to the 1/3 power. Okay, so if I have x to the 1/3 power, then you know what that really ultimately becomes is going to be the cube root of x. Okay, we wanted to write our answers either with a single exponent, not an integer exponent, or as a radical. Okay, so that's how we do those. So I hope you enjoyed this video. I know this is kind of a tricky section, but you know, practice makes perfect, and we'll see you in a bit. Thanks a lot. Bye.